Hello and welcome to this quick pitch video on the R1511P embedded 3G 4G router. The R1511P was launched by Robustel to help catalyse the growth in the cellular IoT market by offering a small footprint, cost-effective solution that in some instances can actually replace existing 4G module-based PCB designs. So let's dive straight in to the details on the product. So this is the embedded R1511P router. It's a single PCB with a single SIM card holder, has two Ethernet serial ports. There is a digital I/O version available as well now. Standard 9 to 36 volt input range, and there are mounting holes for this to be screwed onto a backplate into some existing product. And as you can see there, the product label has certification, end product certification for the device. So what the strategy behind this, as we alluded to, is there are definitely challenges when you're making a product, an instrument, or a machine, maybe a medical instrument, that in which you want to maintain a cellular connection or a cellular option, but the actual machine is expensive. The annual volumes might be around 500 a year, and maintaining all facets of the cellular subsystem can actually prove to be quite expensive, especially if you're hit with chip shortages or end of life of modules and things like that. So for some of those people, the business case is actually really strong to use an R1511P. The other thing we are seeing with the R1511P, because of the way it's supplied, it's much more lean and production ready. And we'll come on to that shortly. So if this does look like the product for you, the way to get started is to speak to your local Robustel representative about getting a development kit. It's basically an R1511P with all of the connectors and some breakout blocks that might be useful to get started quickly. This is a very important subject that we see increasingly. Many of our customers that are sourcing routers from non-Robustel routers are complaining, for example, that each router is packed in quite a big retail-ready box, and maybe in that box there is a power supply with every router. So they're accumulating more and more unrequired items that ultimately becomes waste, and certainly in Europe needs to be dealt with under the WE directive. So for the higher volume users, it's not a desirable place to be. So this is much more in line with a production process. And literally, we are offering a router as a component of part of a bigger system. So a typical application for the R1511P, I'm sure some of you will recognize there as a single board computer. We've used the famous Raspberry Pi to fill that space. And indeed, customers are using the R1511P as a cellular subsystem for single board PCs like the Pi. So either Ethernet, which would be the most common, or possibly even RS-232 if that's how you wanted to make a connection. Maybe there's some cyber consideration to have an air gap, and so you can use a serial protocol. That will connect into the 1511P, and then that's where the router functions come in, and we can route those packets over Ethernet, Wi-Fi, 4G, or a combination thereof. Maybe we'll have Wi-Fi as the primary and then fail over to 4G in fault conditions. So there's a huge amount you can do through the typical router graphical interface. So who are the customers for the 1511P? Well, it's, as we've alluded to, system integrators putting devices into panels. Often they don't need housed products. And what they do want is volume, bulk packing, low cost of shipments, and production-ready boxes that are easy to install. And as we also touched on at the start, design engineers currently might be looking at a PCB-based design, a fully integrated design with a cellular module on the board, but the volumes on that product maybe have dropped to only a few hundred pieces a year. And at that point, maybe taking the R1511P as a subsystem off the shelf makes more commercial sense than doing your own. So we're not going to go into all of the fine detail of this slide, but this is quite a nice story about if you use an embedded 4G router from Robustel versus a typical industry standard 4G module. I've picked on a mini PCIe 4G module because it's a slightly closer comparison. It's socketed, so you might have that socket inside your machine or on the motherboard already. And so a few benefits just to cherry pick from this list in hardware and software. So one of the things we made a point of doing with the R1511P is making sure it's end product CE certified. Now, I know CE plus CE does not equal CE, but I think to know that the product, we can share the EMC test report under NDA, and that should give you some confidence if you want to design it all into your enclosure. Conformal coating option, it's not an option, it's now been determined that's how the 1511P is provided as standard. So just offers that little bit more protection, maybe in nasty corrosive environments, maybe by the seaside. You have a very saline environment. Might just keep things a bit healthier for a bit longer. Clearly, if you use just a 4G module, you don't get Wi-Fi and Ethernet, and with routable interfaces as well. So that would be something else to consider. And just about everything really that is in Robustel's 100,000 lines of source code to build the router operating system, somehow you're going to have to build that from scratch. Even if you can cherry pick components from a Linux environment, you've still got to consider how to do that. So that's just an idea of pros and cons. And this is one of the early adopters of the R1511P. I thought it was a really nice testimonial that Steve was kind enough to share with us. So the R1511P is ideal. It solves significant problems for a little extra BOM cost. Adding something like this from scratch internally involves writing a dialer, studying module data sheets, implementing correct power supplies, good layout, and possibly changes to existing, already proven and productionized PCBs. Understanding the use of AT commands for driving 4G modules can also be a black art. Considering the significant number of risks in software certification and testing, with this product, I can quickly identify the requirements, what impact it's going to have on certification, and minimize the overall development. Robustel's system on module approach, like that framing from Steve, that's not something we had considered, but you can think of the 1511P as a system on module. So this approach offers a risk-reduced method of integrating a complex device into small to medium production runs, essentially trading an increase in bill of materials cost for less risk and quicker time to market. So beautifully put. Thank you to Steve. You know who you are. Now this brief comparison of a Raspberry Pi and an R1511P is really a nod to the fact that they are both fundamentally, Linux computers. And so we've done a little comparison here just to get people thinking that if what you're actually doing, if the code you're executing on your Pi is not CPU intensive, then maybe you can do everything on a 1511p using the capabilities on board for typically for something like protocol translation or an MQTT client between a Modbus device and the cloud. So the 1511 is pre-approved, conformally coated. They're both Linux-based devices. They're both programmable. Obvious delta here is 1511p is designed to a very tight cost budget. So the compute power in a Pi is significantly higher. So if you need fast floating point calculations, this isn't a consideration. If you're just manipulating some ASCII, so say MQTT, HTTP posts, then potentially a 1511p alone is perfectly fit for purpose. And there's a nice router GUI and watchdogs, etc. So just food for thought there. Now, a big part of Robustel's proposition these days is the cloud platform. Now, the basic version, which is read-only, is completely and utterly free of charge. And that includes the cell triangulation-based mapping that you see on the page there. So instantly, you've got a whole load of Microsoft Azure infrastructure free of charge with your R1511P if you adopt that approach. Another feature in the cloud platform is Robust VPN. Now, this is a chargeable tool, but you can use it on a as and when, on an ad hoc basis. So you can make an outbound connection to your R1511P and the devices connected to it anywhere in the world at any time on any bearer. So that could be Ethernet, Wi-Fi, 4G, IoT SIM, or even a 4G just local supermarket SIM. So in essence, you have your own open VPN access server stood up in the cloud ready to go if you need it. If you don't need it, you don't pay for it. So that was a whistle-stop tour of the R1511P. Please contact your local Robustel representative if you'd like more information, or you can email support@robustel.com. Thank you very much for your time. Goodbye for now.